DynamoDB is a powerful NoSQL database. It's fast and scalable. But to unlock its full potential, you need to understand indexing. Think of indexes like a table of contents for your data. They help you find information quickly. Without indexes, DynamoDB has to scan your entire database to find what you need. This can be slow, especially with large datasets. Indexes solve this problem. They provide a shortcut for DynamoDB to access your data efficiently. DynamoDB offers two types of indexes: local secondary indexes, or LSIs, and global secondary indexes, or GSIs. Both LSIs and GSIs allow you to query your data in different ways. Understanding the differences between these two index types is crucial. By mastering DynamoDB indexes, you can optimize your database for performance and build applications that can handle massive amounts of data. Local secondary indexes, or LSIs, are a powerful tool for querying data within a single partition of your DynamoDB table. They are called local because they are tied to the same partition key as your base table. Imagine you have a table of orders with the order ID as the partition key and the customer ID as a sort key. You could create an LSI on this table using the customer ID as the sort key. With this LSI, you could easily find all orders for a specific customer. LSIs are limited to the same partition key as your base table, but they offer some distinct advantages. First, LSIs are updated synchronously with your base table, ensuring data consistency. Second, LSIs can improve query performance by allowing you to query on attributes other than the primary key. Global secondary indexes, or GSIs, unlike LSIs, provide a global view of your data. They allow you to query your entire DynamoDB table using a different partition key and sort key combination than your base table. Think of GSIs as separate indexes that are loosely coupled with your base table. They are updated asynchronously, which means there might be a slight delay before changes in your base table are reflected in your GSIs. GSIs offer immense flexibility in querying your data. For example, you could create a GSI on your orders table using the order date as the partition key and the customer ID as the sort key. This GSI would allow you to efficiently query for all orders placed on a specific date, regardless of the order ID. Now that we've explored both LSI and GSI, let's compare them head-to-head. LSIs share the same partition key as the base table, while GSIs can have a different partition key. Both LSIs and GSIs allow you to define a different sort key than the base table. LSIs are updated synchronously with the base table, ensuring strong consistency. GSIs are updated asynchronously, which may lead to eventual consistency. GSIs offer better scalability than LSIs because they are not tied to the base table's partition key. GSIs generally have a higher cost than LSIs because they require additional storage and processing power. LSIs are ideal for querying data within a single partition, while GSIs are better suited for global queries across the entire table. Section 5. Practical use cases for LSI. LSIs are particularly useful in scenarios where you need to query data within a specific entity. Let's say you're building an e-commerce application and you need to retrieve all the products within a specific category. You could create an LSI on the product category, allowing you to efficiently retrieve all products within that category. This approach avoids costly scans of your entire product catalog. Another practical use case for LSIs is in social media applications. Imagine you have a table storing user posts. You could create an LSI on the user ID and the timestamp to retrieve a user's posts in chronological order. Section 6. Practical use cases for GSI. GSIs shine when you need to query your data using different access patterns than your primary key allows. Let's say you're building an online forum, and you need to display the most recent posts across all forums. You could create a GSI on your posts table using the timestamp as the partition key and the forum ID as the sort key. This GSI enables you to efficiently retrieve the most recent posts across all forums without scanning your entire database. Another compelling use case for GSIs is in analytics. Imagine you have a table tracking user events on your website. You could create a GSI on the event type and the timestamp to quickly analyze user behavior patterns. Section 7. Choosing the right index, LSI or GSI. Choosing between an LSI and a GSI depends on your specific needs. Here's a simple decision-making flowchart. 1. Do you need to query data using a different partition key than your base table? Yes. Use a GSI. No. Go to step 2. 2. Do you need strong consistency for your queries? Yes. Use an LSI. No. Use a GSI. Remember that each index adds storage and processing overhead, so it's crucial to choose the most efficient indexing strategy for your workload. Section 8. Conclusion. Mastering DynamoDB indexing. Mastering DynamoDB indexes is essential for building high-performance applications. By understanding the differences between LSIs and GSIs, you can choose the right tool for the job and unlock the full potential of DynamoDB. Remember to carefully consider your access patterns, consistency requirements, and scalability needs when designing your indexing strategy. With careful planning and a deep understanding of DynamoDB's indexing capabilities, you can build applications that are both powerful and efficient.